Methodical and engaging. Building a complete employee registry system requires tying together two entirely different environments. We have to merge the strict logical rules of a back-end object-oriented structure with the dynamic visual elements of a front-end graphical interface. To start, we define our base data model using a person class. Notice how we restrict access to our variables. We set the name variable to protected, allowing any future child classes to access it directly, while locking the age variable behind a private access modifier to keep it entirely isolated. To actually use this class, we provide two ways to initialize it. The default constructor sets a baseline, giving us an object with blank or zeroed out values. The parameterized constructor requires specific data inputs up front, allowing us to populate the object the moment we create it. Both methods share the exact same class name, but their distinct parameter lists tell the program which one to execute. When we are ready to bring this blueprint to life, we use the new keyword. This command instructs the computer to allocate physical system memory and generate a discrete object containing the specific data we passed in. Establishing this rigid blueprint early on guarantees that our core data structure remains secure and predictable. We need this stability in place long before we introduce a graphical interface, where user inputs become highly unpredictable. This diagram illustrates inheritance. As we move from the purple base classes block down to the derived class block, we see how an existing structure is used to create a new one. For our registry, an employee is a specialized extension of a person. Looking at the syntax in this image, you establish this is-a relationship in Java using a single word. The highlighted red box shows the extends keyword connecting the new class name to the existing class name. When creating an employee, the child class must initialize inherited variables by passing shared parameters to the parent constructor using the super command. Next, we customize behavior through method overriding, replacing the parent's toString method to output the subclass's tailored data. Building this hierarchy lets us reuse the code from the person class across dozens of potential roles, managers, contractors, or interns. This structure prevents massive code redundancy as the overall system complexity scales up. With the logic defined, we transition to building the interface. Modern Java development relies on the Swing library over the older AWT because Swing components are lightweight and cross-platform. Writing the code for a JLabel, a JText field, and a JButton generates corresponding visual elements on screen. But this visual button is inert until we register an event listener, attaching the addActionListener.this method. When the action performed trigger fires, getText pulls the user's input, requiring strict syntax to cast string data into an integer. For multiple buttons, event.source identifies the specific trigger, acting as a traffic director routing execution flow to the correct logic. Without this event-driven architecture, a graphical interface is just a static painting. Connecting the listener is the exact step that transforms drawn shapes into functional software tools. Let's see how all of this operates together. A user types an employee's details into the text fields and clicks the Submit button. That single click initiates a complete lifecycle. The data travels from the graphical view into the controller via our action listener. The controller casts the text to integers, then instantiates the model by triggering the inherited employee constructor. Finally, that newly structured object is formatted and rendered right back to the view. To engineer complete software systems, you need both sides of this architecture. You apply strict object-oriented inheritance rules to manage the logic, and you wire dynamic event-driven components to handle the user interface. When you lock those two halves together, you have a fully functional application.